Okay, now I give you that the derivative of sine is cosine and the derivative of cosine equals negative sine, and I showed that that was consistent graphically without giving a formal proof. However, I am able to use that fact, or those two facts, to prove the derivative of the tangent of x, the derivative of the secant of x, the derivative of the cosecant of x, and the derivative of cotangent of x. We will start with the derivative of the tangent of x. First of all, we know that the tangent of x equals sine of x over cosine of x. Then it would flow that I can take the derivative of this using the quotient rule, which would give me the derivative of the top, sine of x, which is cosine of x, times the bottom, minus the top, times the derivative of the bottom, and the derivative of cosine is negative sine of x, all over the bottom squared. If I simplify this a little bit, you should easily recognize I'm dealing with cosine squared of x plus sine squared of x all over cosine squared of x. Sine squared plus cosine squared you should recognize as the trig identity for 1. So I have 1 over cosine squared of x. 1 over cosine squared of x can also be written as, hang on, secant squared of x. So I have my first derivative. I did this proof using the quotient rule. So the derivative of tangent of x is secant squared of x. Second example I will do is the derivative of secant of x. So for this one, we're going to start off with the secant of x equals 1 over cosine of x. And then again, I'm going to use the quotient rule to take the derivative of the secant of x, which will equal the derivative of the top, which is 0, times the bottom, minus the top times the derivative of the bottom, which the derivative of cosine is negative sine of x, all over the bottom squared. So I end up with sine of x over cosine squared of x, which can also be viewed sine of x times basic fraction property here, which gives me tangent of x times secant of x. So the derivative of the secant of x is tangent of x times secant of x, or secant of x times tangent of x, which is my second property. And again, I will continue with this. Now we're dealing with cosecant using the same technique. We know that the cosecant of x is 1 over sine of x, which means the derivative of the cosecant of x is the derivative of the top times the bottom, minus the top times the derivative of the bottom, and the derivative of sine is cosine, all over the bottom squared. which will give me negative cosine of x over sine squared of x, which can be written as negative cosine of x over sine of x times 1 over the sine of x, which is negative cotangent of x times cosecant of x. So the derivative of cosecant is negative cotangent cosecant of x. And last but not least, the derivative of the cotangent of x. And I'll work that out with the cotangent of x equaling cosine of x over the sine of x. Then the derivative, using the quotient rule of cotangent of x, will equal the derivative of the top. And the derivative of cosine is negative sine times the bottom minus the top times the derivative of the bottom. Derivative of sine is cosine all over the bottom squared. And I'll simplify this. And the top by Trig identity is negative 1 over sine squared of x, which is negative cosecant squared of x. So, got the tangent now. Is negative cosecant squared of x. So, that is how I found the derivative of the other four trigonomic identities using the quotient rule and their definition based in sine and cosine.